4-3. 4-3. And someday I've got to get to lesson 6, 7 in every class, aren't I? It's gonna happen.
Yeah. No, I just flipped the whole road leads around. I flipped to 6-7.
It'd be hilarious if it was what I'm planning to skip. Oh, I ain't skipping that. No skipping that one.
No.
We'll definitely be doing that one. So okay. There it is, the big day. Mixed numbers and improper fractions. Something you already know how to do. You should know how to write these as improper fractions, and you should know how to write these improper fractions as mixed numbers right now, right?
Yeah,
Should I start counting them out? What's the answer? I could. I don't want to ruin your January for you like that.
Now we got 2 more chapters.
Right. Okay, evaluating algebraic expressions. So we are going to learn something new over here, and it is a significant piece of the algebra puzzle of your life here. Significant. This right here. It's a huge deal. But before we do that, we have some of these algebraic expressions here. Again, looking at your homework here. Never mind. Okay. You will notice this homework is quite a bit more involved than it was when you did 4-1. Maybe you've already looked at it. There's really not a lot of problems. There's only 10 problems. But they will take time. No doubt about it. You should have a big chunk of work for me tomorrow. All over the place work. So it will take time. A lot of them are like PEMDAS problems, essentially. So you're going to be doing your PEMDAS type work. There's decimals in almost pretty much 1, 2, 3.
Don't even trip on.
So in your homework here, I'll write this down, but there's 2 parts, 1 through 4. 3 of the 4 of them have decimals in the answers, but the second part, 5 through 8, none of them have decimals. Right. So you can jot that in your workbook or notes or remember it. It's 2 parts, 1 through 4. 3 of the 4 answers have decimals. 5 through 8, none of them have decimals. Okay. As for the ones today that we're about to do, I'm looking at page 126, by the way. See them at the bottom there? Look at that fun stuff. That's what we're about to do. 2 of the 4 have decimals. So maybe there's a decimal in the answer, maybe there's not, right?
Get right to the 6 so we can have more time.
So 56 minus P, Q, and we're not to sticks yet. So this is what I see here. Then next to that, I see when Q equals, or when P equals 3, and Q is 4 2/10. R is 5 1/10. So this is generally, remember 311 here?
Yeah.
Did we play the song?
Yeah.
Great.
Lay down.
That's good. So this is what we did here. Guys, shh. Speaking of which, you need a few minutes to finish the quiz, don't some of you? Or is that 5th grade? Yeah, that's 5th grade. Never mind. My bad. Well, remember when you did this? Right? Whenever you see a C, boom. Whenever you see a D, boom. Well, same deal here, except they just see the problem. It changes, as you can see. So plug in what you know. You're going to have to rewrite at some point, but P is 3 times the sum of these. So again, all I do is just plug in. There's P, there's Q, there's R. There's P, there's Q, there's R. Easy enough. So PEMDAS rules tell me parentheses first, right? So what's 4 and 2/10 plus 5 and 1/10? So now I got 56 minus 3, and again, this is multiplied. This is multiplied. P times. This is multiply. This is multiply. This is multiply, right? So I'm switching the symbol in this way. It's the same thing. If I want to just leave it like this, I mean, this is multiply too, right? We've talked about it a lot. Multiplying can look a lot of different directions. This is one of them. What do I do next? Right, always do multiply before subtract. What's 9 and 3/10 times 3? 27 and 9/10. So now I'm left with 56 minus 27 and 9/10. Only thing left, I should rewrite 56 probably this way. All right. A 1, an 8, and a 9. That's not, what did I do here?
You subtracted 4 and 2.
Why did, oh, I made this an 11 for some reason here. Why did I make that an 11? So final answer, 28 and 1/10. So again, just plug in the values, solve the PEMDAS-esque problem that's before you. Parentheses first, exponent second, multiplying, divide third, add and subtract fourth. As I think we learned not too long ago, the order matters a lot here. If you do anything wrong, you're going to get a very different answer, also known as the wrong answer. Okay, why don't you guys try, we'll just do numbers 2 and 3.
I was hoping you didn't say 3.
I haven't really looked at them that much. Guys, 2 and 3.
That's what I happen to be doing.
And it says x is 3, y is 8 and 8/10. Z is 4. You have all that info in front of you. Number 2, number 3, bottom of page 126.
I hope I got 2 right.
Is there remainders on any of these? I assume not.
There's no remainders. Some have decimals, some do not. For these two, one has a decimal, one does not. Clearly, this one, there's no decimal. There's no decimal at any point anywhere in the problem. So
Easy.
you can probably conclude if one of these two have a decimal in the answer, which one it's going to be. And in your homework, 1 through 4, 3 of those have a decimal, 5 through 8, none.
I like these problems. They're pretty easy.
These are always some of my favorite types of problems. The bigger and longer, the better, I used to say. Then we got to talk about the next thing.
Can we just get straight to the sticks and just be done with the lesson?
Huh?
Can we just get straight to the sticks and just be done with the lesson?
George, be quiet.
Truth be told, we haven't really covered anything new at this point here. Like, this is more reviewing things you should already know how to do. All this work here. Because we've done this before, right? I just showed you, we've done this before. We haven't really done a lot. You know, here. once we finish these two problems, then we'll talk about our new thing, our new and exciting thing. All right. So first thing I would probably do is rewrite everything with numbers. And I hope you would do the same thing instead of, I challenge you not to say, well, I could do that in my head, and I did that, and I did that in my head, and it's a poor strategy for a lot of you. Maybe one or two of you could get by with that I know you have enough concepts of your tables, but the other four of you, five of you, maybe 4 or 5, I don't know, you should not trust yourself to, I can do that, and that all in my head, so I'm not going to write anything down. Be a poor strategy. Okay. Roland, what do you got? What are we seeing? What are we doing?
So for number 2, 3, we do the parentheses first. 3 plus 1 is 4, and that's squared.
Yep.
So that'd be 16.
Yep. And then from that point on, it's probably pretty straightforward. We're just adding 3 numbers together. What's the answer?
18 and 8, 10. Or wait, no.
What's 16 plus 4?
24.
What's 16 plus 4?
Oh, 20.
Plus 8 and 8/10?
28 and 8.
Right. Right. I would add 6 plus 4 first, personally, instead of the other, right? I get a nice little 10 family they gave me right there. So 28, we're not, that can't be right. It's not what the book has. What did I do wrong here?
You added the 4.
Am I supposed to add Z?
Divide Z.
Oh, divide Z. I wrote add Z. I didn't, okay.
Yeah, and then 4 goes
Well, then,
to 8.
let's back this whole thing up here a bit, because none of that's right at this point. So we are not adding 3 numbers together at this point. So what do I do next?
16 plus
Roland.
So 4 goes into 8 2 times.
Right, division. What's that answer?
16 plus 2, and then there's an 8 left, or 8 tenths left over, so it's 18 and 8 tenths.
Isn't it 2 and 2/10?
Oh.
4 times 22 is 88.
Okay.
So 16 plus 2 and 2/10 equals?
18 and 2 tenths.
Right. There we go. Right. It's still hard for me to see that division thing here. Number 3, George. I will help. So
Alright, so we're
C
gonna start off with the
times
CJ.
J cubed. So there, I plugged in the 6 and 5.
Yeah. So the CJ, you have to multiply that to equal 30.
Nope.
No?
You're doing multiplying and dividing before the E.
Yeah.
You do exponents first.
Oh.
Exponents before, that's the E in
So,
PEMDAS. You're doing M before E. Michaela. Lauren,
Number 3.
what's 5 cubed?
What's 5 cubed? Wait, what?
5 to the 3rd power is?
The third power is
George?
125.
Yeah, it's 100.
Okay, so I did. Oh, I was
You don't
doing
have
5
that
to the
number in
fifth.
your paper? Did you do it
No, I
wrong
was
too?
doing 5 to the 5th.
Well, you should have just
Oh, wait.
go look down and go 5 up 125.
I didn't have 125.
Alright, so George, what do I do next?
And then you multiply 6.
Times 125.
750.
Yep, plus 15.
Then that would equal 765.
Okay,
765. That's it. That is correct. Good. So, right, little bit of PEMDAS thrown into the mix here. I mean, plugging in the value for the letters shouldn't be hard to do at all. But it'll come down to PEMDAS. And these aren't crushingly difficult things to solve by hand. I can't guarantee you that your homework will be as nice to you about it, meaning the homework ones are a bit more challenging than this, unfortunately. But there's only 10 of them, right? So bear that in mind. All right, let's look at page 127. This. I'm going to write number 5 down, I suppose. And then we're going to talk for a moment here. And then it says when n equals 2 and 5/10. Right? So I think I'm going to backtrack this even further. So I'll come back. I'm going to make a new problem up myself. Ready? 4n plus 2n plus 3 when n equals 2. Okay.
So those are two problems.
Right. Yeah, I'll start with this one. So it says combine like terms. So there's two different things we need to understand here. And this is major information here. Major. Very major. You won't utilize it much the rest of the year. I mean, you'll definitely use it this chapter. And then the last handful of days in May, you'll utilize it again. Before summer vacation, we'll be utilizing this concept again. You'll utilize it more in 7th grade, and then you'll utilize it even more in 8th grade. So, but it's a huge deal. It's combined like terms. Combined like terms is a process done. I've described math problems to you as a 3-step, kind of a 3-realm problem, right? You got your pregame work, stuff you got to do to solve a problem. And then you can actually solve the problem. But as it gets more complex, your math, you're going to realize you have more pregame work to do than you've had at any point in your life. Most of your math life, you've had no pregame. You just solve the problem. And then the final step is simplifying, which you've had to do that at times, especially with fractions work. You'll get your final answer, but you have to simplify it. It's not in the right form or something. So you've done that step. But you haven't done a lot of step 1, pregame. Combining like terms is pregame work. It's work you do before you even start solving the problem. Meaning, I need to combine like terms before I say n equals that. Pregame work. So my goal is not necessarily to solve the problem right now. It's to simplify the problem into a better form. So when I want to start solving it, it's going to be easier to do for me. And to do that, combining like terms. So there's two different things. There's terms and then there's like terms. So a term is basically anything. That is a term, 20n. That is a term, 6n. That is a term, 3. That's a term, 3z squared. That's a term, 10. That's a term. That's a term. Term is a number, could be a variable, could be the any power, separated by adding or subtracting signs. All right. Multiplying and dividing, they're combined together to form one term. But that's a term, separated by an adding or subtracting sign. So everything in between, those are terms, individual terms. Like terms, right? Like terms. Because like terms are the ones we care about the most. Like terms need to have two things happen to be a like term. Anybody have an idea what the criteria is for a like term? Two things need to happen. Roland?
They have to be like in the same, like they both have to be division, or like both have to be the same.
Numbers are always like terms. Like if I had 20 plus 4, well, I would combine those like terms to 24, right? I certainly do all that. So specifically, we're talking about variables here with like terms here. All these have variables. There's a y, a z, and n. Because numbers, they are like terms too. And we always combine, whenever we can do a math problem to shorten it down, we always do it. We would never leave it as 20 minus 16. We would combine those like terms and make it 4, right? So like terms, variable. Anybody have an idea? There's two things that we need, two things to be like terms.
The terms have to be the exactly same variable parts.
Right? They have terms that have the exact same variable parts. So what does that mean? Same variable parts. There's two things. So,
Does it mean like the same number?
the same, we're not talking numbers, only letters here. Numbers we always combine when we can.
The same thing, like with if you can't do, it's not a like term if it's like a fraction.
That's a number.
They're worth the same amount.
Like terms are same letters. That's one of the things. Same letters. They, again, variable parts. When I said, what's that? Nobody could tell me that one. It's the same letter. N, X, M. But on top of that, it also has to be to the same power. And they're not really going to show you this in 6th grade here. But to be a like term, two things need to happen. The variable needs to be the same letter, and it needs to be to the same power. If it's not the same letter to the same power, then they are not like terms. They are different terms. They cannot be combined. That's what I'm telling you here. You don't have to write this down here, but if I had, well, I'll come back to it. Let's go back up here. Let's look at this. So now we know, same letters, same power. So could I solve this by plugging this in here, n equals 2, so I'd have 4 times 2, n equals 2, plus 2 times 2, plus 3. 4 times 2 is 8, use PEMDAS. 2 times 2 is 4, 8 plus 4 plus 3, the answer is 15. Would you agree with that statement? The answer is 15. I can solve it faster. I created this one because it's smaller than this one because they're going to want you to solve it. But if I'm combining like terms, what I'm looking for, back to this problem right up here, you can just ignore all that for the time being. Do I have like terms in this problem? What are my like terms? 4n and 2n, because remember this is all one term here. But they are the same variables, n, to the same power, 1. They are like terms. These two terms are like terms, which means I can combine them. So when I'm combining like terms, the variable never changes. But what's 4 plus 2? So what I've done now, when I add 4n plus 2n, when I combine my like terms together, that gives me 6n. Now the 3 here is not a like term because it is not the same variable to the same power. It's just a number. We call that a constant in math, a constant. So there's nothing to combine this with here, right? If I had another thing like say 4n plus 2n plus 3 minus 2, well then I could combine 3 minus 2 together to plus 1. So I combined my like terms. Basically, I took a problem where I had 3 terms. What are my 3 terms in this problem? 4n, 2n, 3. And I know they're in terms because they're separated by a plus or minus sign. But I've turned a problem that had 3 terms into a problem with 2 terms. Right? Now that I've combined all my like terms, now I go ahead and finish it off the way before. These are not as hard on the math. It's more focused on doing this step than solving it. But n equals 2, what's 6 times 2? 12. What's 12 plus 3?
15.
Same answer. Same answer. Still 15, right? But what did I do? Instead of plugging it in and solving this problem equals this, and this problem equals that, and then adding 3 numbers, no, I combine my like terms. I plugged in the variable once, not twice. I solved one problem, not two. I added 2 numbers, not 3. And you're going to see things with more terms, 3 terms, 4 terms, 5 terms. So being able to simplify, figuring out what goes with what is a huge part of your math future here, because problems are going to get more complex, longer. Again, not going to say harder, it's just there's more more processes to follow to get from point A to point B. It's just, you know how to do all this, but now you're going to do this, so when this happens, now you need to be able to do this. And then you add another rule to the network here. I'll carry with you. But this combining like term stuff, this is done before you solve a problem. Before you solve a problem. The first thing I did before plugging in n was I combined my like term. Boom. Pre-game done. Now I'm up to step 2, solve the problem. Plug in the value, do what I got to do, my little multiply, my little adding stuff. There's my answer. Don't need step 3 at the moment. There's nothing to simplify, right? Step 3, not applicable right now. 2-step process. But most of your work is just solve. And again, rightfully so. We need you to get faster and more fluent at adding, subtracting, multiplying, and dividing. And you realize that. We're doing big numbers, we're doing decimals, negatives are coming up next chapter. So we're working on that part here. We're doing that. But yeah, we're getting to a point where we can't add, subtract, and multiply and divide the rest of our lives here, right? Every year is not going to start with us reviewing place values. Let's do some adding, or if we do it, it'll go a lot faster, bigger numbers. So pre-game work, you get used to it. Again, not a ton of it this chapter and not a ton of it this year. So it's kind of oddly dropped in here in chapter 4, but this is what it's all about. If you can remember this, and you will remember it before you're done here. I would bet every 7th and 8th grader could tell you that. I hope so. I've heard it many times, but like terms, same variables, same power. Numbers are like terms. They're no variable to no power. They're like terms, right? We always combine numbers, though. We always have. It's the letters. So if I go up to number 5 again here, I'll just rewrite it since I'm a little ways away here. Again, 2 objectives. 1, I want you to solve it. What's the answer? But that's the secondary objective. The primary objective is by combining the like terms. So for these here, the first thing you're saying is, what are my like terms? Hopefully you're saying 20n and the 6n term here. So this is, in a sense, a negative 6n. I mean, you're not going to have negative values, but what's 20n minus 6n? 14n. When you're combining like terms, you only add or subtract them. Multiplying and dividing is something else. So when you're adding or subtracting, whenever you're combining like terms, you will add or subtract only. Only. But the variable never changes. It's just cover up the variable and do the same thing. Whatever symbol this is tells you what to do. In this case, I'm telling you to subtract. What's 20 minus 6? If it was plus 6n, then you would add them. 20n plus 6n would give you 26n. Right? And then this next part here, again, we didn't touch anything here. The rest of this just comes with me, that minus 3 part. Because my pregame work involved these 2 terms and these 2 terms alone. My pregame work had nothing to do with subtract 3. Right? There's nothing to combine it with. If there was something to combine it with, I would combine it with it. But there's nothing to combine it with. It's not the same as this term. They're not the same variables, the same power. So this part just comes with me to the next part, essentially here. If there's more work to do, more to combine, in later math years there will be. Right now there's not. But then I'd continue. What do I do next? On to the next process. So for now, this is it. But now once I do that, now I can plug it in here. Step 2, solve it, evaluate it, simplify it, whatever you want to call it. So now you're left with your little problem here. What is it? 350? 35 minus 3. 32? Is that the answer? Yep, 32. So, combine like terms, insert the variable for the value, solve whatever you gotta solve. In this case, multiply first, then subtract. It does. Bada bing, bada boom. Can you do that? Great. I'll give you 2 and then we're done here. That one may take a little while. Let's try it anyway. 8 and 9. Huh? Yep. Ten is a fun one too. 10 has 2 different variables in it. But 8 and 9 will get the job done. So combine like terms. What are your like terms? Combine them. Then insert the value for the variable. Solve. Now we got these are our last 2.
One person's gonna get lucky and not have to do one unless they want to do one.
But they're not gonna wanna do it.
Tomorrow's lesson always takes a really long time, so tomorrow I'll be trying to focus to go fast. I'll try. And Friday's our quiz, no new lesson that day. And next week it will at least not be so frantic in the pace, but so on your homework 5 through 8, I want you to combine like terms just like we're doing now. There's no decimals with the like term ones. No decimal in either of these answers. Which makes sense because I don't know how a decimal would appear when you're only multiplying and adding for the most part. Alright. Number 8. So first thing I want to do is write a new expression with combined terms. Ella, what's my new expression when I combine my terms?
10m. I don't know if I put, and then I can remember it's square cube for 2.
Squared. Squared is a 2, cubed is a 3.
Squared plus 2.
Right. Perfect. So these are our like terms right here. They are the same variables to the same power. They can be combined. 7 plus 3 is 10. Variable doesn't change. Now it's a matter of plugging in n equals 3 right there. So now I would have 10 times m, which is 3 squared plus 2. So what?
First you're going to do 3 squared
Right, exponent before multiplying, 3 squared is 9, right?
Then 10 times 9,
Yep,
which is
90 plus 2, 92. Nice work, Ella. Great job. Perfect. Yep, she executed every step in the correct order. Combined like terms first, inserted the value. This is, again, I rewrote it this way just to, so you can see, understand clearly what's going on here. It's 10 times m squared. We do exponents before multiplying. So your next step should be to figure out what 3 squared is. It's 9. 10 times 9 is 90. So, yeah, if you're trying to figure out what 30 squared is, that's 900 plus 2, that's 902. So if you got 902, you did 10 times 30 first. You needed to do, or you did 10 times 30. If you got 62, well then you did that wrong, and then you did times 2 with your exponent instead of squaring it. So then you did 2 things wrong. But I can tell you what you did. All right, number 9. Rewrite me, Stella.
So, would it be rewrite? Would you add 9 and the 3?
What do you think? Are those like terms?
Yeah,
How do you know?
because they both have a z and a 2.
So what's my new expression?
12z squared minus 5z, and then
Do you guys agree with that? Right. Well, hold on. This is correct because, again, I wanted to see. I mean, this is why I said, remember, there's 2 pieces of criteria. The same letter is one of the 2, but to the same power. So if I go to this one here, this is Z2, this is Z2. I can add these 2 together. It is 12, but this is not Z2, is it? This is just Z. This is not, these are not like terms. This is different from these 2 because it's not to the same power, not a like term. So if you were able to get this equation here, or expression, good, good. That's what I need you to understand. What a like term is. Same variable, yes, but also to the same power. This one, it does meet the same letter criteria, but it does not meet the same power. So then I'll finish it here, same deal. 10 squared is 100, 5 times 10, 12 times 100 minus 50. 1200 minus 50 is 1150. I know it's time to go. So there you go. Thank you. Sorry I kept you a little late. If you want to question it with me, you can ask me.